Welcome to this course on Abaqus. In this lecture, we are going to solve a one-dimensional beam problem. So first we will solve some very simple problem. After that, we will move on to some complex problems. So in Abaqus, first of all, we are going to define what is our problem. So in this problem, we can see we have a beam. Now this beam is fixed from the left side, and on the right side, we are pulling this beam with a force of this value. Okay, so the length of this beam is 500 mm and the cross-sectional area of this beam is rectangular in cross-section and the value is 10 by 10. And the material properties for beam are specified. We are considering the material as a steel, and the Young's modulus of the steel is value of E is equal to this value, and Poisson's ratio is this 0.3. And now we are following the units into this problem, that is Newton mm second. So analytically, if we want to find out the value of stresses and deflection, we will find out that stress is given by force divided by area. So this is the value of force, and the area we can calculate by multiplying this 10 and 10, and the value of stress that is turned out to be 1000 megapascal, or we can specify this on units Newton per mm square. And the value of deflection is given by FL by AE. So F is force, L is length, A is area, and E is Young's modulus. When we insert all these values, the value of deflection turned out to be 2.38 mm. And now we are going to solve this problem in the Abaqus software. So let's go to Abaqus. So before going to Abaqus, we need to understand what are the steps involved when we create an analysis in the Abaqus. So first of all, in Abaqus, we need to create a part. So the first step is creating the geometry. In this geometry, we are going to create the part. After that, we need to specify the material. So here we will insert all the values of material properties. After that, whenever we deal with beams, we need to sketch the profile of beam and also the beam orientation. Then we will need to create section assignment, instances. So we will cover them in depth later in the course. After that, we need to create step, boundary conditions, load, create the mesh, creating the job, and we need to visualize the result. So we are going to follow these steps one by one. So first of all, we need to create the part. So now let's go to Abaqus. So in Abaqus, first thing we have to do is go to this file option, go to new model database, and select with standard and explicit model. After that, we need to go to this model tree on the left side. Right now we can see option is highlighting, that is model. So we need to click on this plus symbol. In this, we can see the name model 1. In the model 1, the first thing it is highlighting, that is part. So I go to this option of part, make a right click and go to create. After that, we need to specify what type of part we are creating. So here are the options: 3D, 2D, axis symmetric. So we are going to solve this problem as a 2D planar. So select 2D planar, and then type of the body. So deformable, discrete rigid, or analytical rigid. So we are going to create this body as a deformable body. So select deformable, and then the type of feature, shell, wire, and point. So this is a one-dimensional geometry. So we are going to select wire into this. Select the wire option, and we can also insert the name from here. So let's say I insert the name beam part. Okay, and then we have option of approximate size. So this is the approximate size of this complete geometry. So let's say initially I'm going to take this value as 10 and then click on continue. And right now we are in the sketch workbench. So in this, we are going to create the section of the beam. So we are going to define the length of the beam. To define the length of the beam, we need to create a line. So I go to this option of create lines. Click on this line, and as we already know, the length of the beam is 500 mm, and we are going to create this beam along the x-axis. So go to this create lines. Here is the option pick a starting point. Now we can select the starting point by clicking in somewhere, or we can also create the line using the xy coordinates. So let's say our initial coordinates are 0 and 0. I'm going to start from origin. So here insert the value 0, 0. These are xy value and then press enter. So this is the starting point. After that, the length of the beam is 500 mm. So once again we need to select the end point of the line. So I select 500, 0 and press enter. And then press escape to escape from this line command. And then click on this auto fit view. And now we can see a line of length 500 mm has been created. Click on this option of done. Now there is option of highlighting, sketch the section for the wire, and click on this option of done. So here we have defined the length of the beam. After that we need to create the material for the beam. So go to this option of material, make a right click and click on create. In this window we need to specify name of the material, so it is steel. We can insert some description here. So right now I am leaving this as a blank. Now we need to insert the properties of the material. So go to this mechanical option, mechanical, go to elasticity and go to elastic. So we are going to specify the elastic properties of the beam. Whenever we solve the non-linear problems, then we will define the plastic properties. So right now it is a linear problem. So I go to this elastic and click on this. Here the first thing it is showing type of material, so it is isotropic. It means the properties are homogeneous along all the dimensions. So I am selecting isotropic, and right now I am not selecting any option like temperature dependent, compression, tension, nothing. So I need to insert the value of Young's modulus from here. So value of Young's modulus is 210, 21 and 40, and the value of Poisson's ratio is 0.3, and click OK. So the material property has been defined. After that we need to create the beam section. So I go to this option of section, and here we can see beam profile. So go to the profile, make a right click and click on create. We need to select the type of beam profile. So the type is rectangular, and now name, so we can insert the name beam profile and click continue. Now it is showing name is beam profile, shape is rectangular, and now we need to insert the value of A and B. So value of A is 10 and the value of B is 10. Click OK. So now we have defined the beam profile. After we have defined the beam profile, we need to create the beam orientation. Here we can see we need to create the beam profile and then beam orientation, and then we need to assign this section and instances. So I go to Abaqus. Now to assign the beam orientation, we have to go to this option of assign and go to beam section orientation. Now it is showing select the region to be assigned. So I click on this beam section. Now it is highlighting. We can give it some name here and click on done. So here basically we are going to define that in which direction the beam is going to bend. So I am going to take the default values and click enter and click OK to continue, and after that I click on this cancel procedure. So now we have defined the beam orientation. After that we need to create a section. So go to the section option, click on the section, make a right click and click on create. I select this option of beam and insert some name like beam section. So type is beam and click on continue. Here we have two options. We need to assign the beam section during analysis or before analysis. I am going to select during analysis. Now we need to assign this profile to this beam. So I am selecting the beam profile we have created, and now I am going to assign the material to this. That is the material we have already created. Now section Poisson ratio, once again this is 0.3. So temperature variant, right now I am taking this as a default, that is linear. So click OK to continue. We have some more options like stiffness and fluid inertia. So right now I am leaving all these values. I am going to take this problem as a very simple problem and click OK. So now we have created this section. After that we need to assign this section to this part. To assign the section to the part, I need to go to this part. Click on this plus symbol and click on this beam part. So once again click on this beam part, click on this plus symbol. Here we can see section assignment. Click on this and make a double click. Now it is showing select a region to be assigned. I select this region and click done. Now we have already created a section beam and now we are going to assign this. So click OK to continue. So now it means the section orientation and the material properties we have created now has been assigned to this part. After that we will continue this lecture in the next video. Hello friends, welcome to this course on Abaqus. In the previous lecture we are working on a beam problem, and till now we have created a beam section and we have assigned this beam section to the part. After that we are going to go to the next step, and the next step in creating the analysis is we need to create the instances. So till now we had followed the 5 steps and we have created a section assignment. Now we need to create the instances, then step, boundary condition, load, mesh, job and result. So go to Abaqus. Now we need to create the instances. So basically instance option is very useful when we work on assemblies. So go to this assembly option. So right now we don't have any assembly. We have only one single part and we are going to create instance of that. So click on this option of instance, make a double click on this. And now we can see our part is highlighting. Just select this part option. Now our beam part we have created is showing. Select this dependent and click OK. Now an instance has been created. So whenever we work on assembly, we need to create the multiple instances. So that is where this option is useful. After that we need to create the step. So I go to this option of step. So make a check on this minus sign and go to step. Double click on this step. So in step option, we are going to tell the software that what type of analysis we are going to perform. So in this we have multiple options, like we are going to select temperature, displacement, thermal problem, implicit, explicit. So right now we are going to solve this as a static general problem. So the procedure type is general and it is static. We can insert some name to this, like this is linear beam. And now insert the new step after initial. So in Abaqus we need to define at least 2 steps. First step will be initial step and the second will be the step we are going to define as a linear problem. So go to continue, and after that we need to insert some basic description to this. So we can specify some description and then the time period. So since we are solving this problem as a linear problem, so we are going to define this for a time period of 1. Whenever we solve any problem for a longer period of time, for example when we work on dynamic problems, we need to increase the time period. Okay, then there is option of non-linear geometry. So right now we are solving this problem as a linear problem. When we solve the non-linear problem later in the course, we will know about these options. So right now I am selecting this as a off, and then there is a incrementation option, so automatic and fixed. So we will cover these options later in the course. So these are basically the steps by which the Abaqus is going to solve this problem. So take these values as default as defined by the software. Okay, then other. So everything we are going to take this as a default and click OK. So now we have defined what type of analysis we are going to perform. After that, we need to define the boundary condition and loads. So below we have the option of BCs, that is boundary condition. So go to BCs, make a right click and click on create. The name is BC. Now steps. So here we are going to use the initial option. So in the initial step, we are going to fix our geometry. So here we are going to tell the software that onto which point the geometry is fixed. Okay, so category is mechanical and the type of selection I am selecting displacement and rotation. I am going to fix the rotation and displacement. So click on continue. Now we need to select the region where we want to fix this. I want to fix this beam from the left side. So click on this node. Now this point is selected and click done. So I want to fix this beam in the U1, it means X direction, U2 that is Y direction, and UR3 is the rotation with respect to third dimension, that is with respect to Z axis. So make a check on this. So I want to fix all these degree of freedoms and click OK. So now we have created the boundary condition. Now we are going to define the force. So to define the force, we need to go to this option of load, make a right click and click on create. And now we are going to define this force in the step we have created, that is linear static beam. Select this and the category is mechanical. Here I am going to select that is concentrated force. Here we have some more options like movement, pressure, surface traction, pipe force, etc. So all these options are for different type of analysis. I am selecting concentrated force and click continue. Now we need to select the point where we want to apply this force. So I want to apply this force onto this endpoint. Click here and click done. And here we need to specify the value of this force. So it has CF1 and CF2. So concentrated force I want to apply only in the X direction. So only insert the value in X direction. So the positive X is going, we can see from this axis, is going in the right direction. So insert the value of force, that is 1, after that 5, 0. And in the Y direction there is no force. And the amplitude is, I am selecting RM and click OK. So when I zoom out from here, we can see the symbol for the force. So it means we have created the load and boundary conditions. So after we have created the step, boundary condition and load, we need to create the mesh and job. Now we need to create the mesh. To create the mesh, I go to this part once again. Okay, so this is model. So make a check on this. So expand this model. In the bottom we can see mesh. Right now this mesh is showing empty. So make a double click on this mesh. And now we can see right now we are in the mesh workbench. So it is module, that is mesh. If I click on this arrow, we can see part, property. So all these options are according to the steps we are following. So right now I am in the mesh module. So here we have some option like seed part, then mesh part, etc. Also the similar options are available from the top. So we can select this option from here or also from here. First thing, we need to seed this. Click on this seed and click on part. So in the seed we are going to define that how many number of elements we are going to create. So let's say I'm selecting this 10 and click OK. So all these symbols are highlighting are the division of this beam. I click on done option from here and then go to mesh and go to element type. Now it is showing select a region, so select this region and click done. Here we are going to tell the software that we are going to do the mesh for a beam problem. So select beam here. This is standard and geometry is linear and click OK and click done from here. And now we are going to create the mesh. So go to mesh, go to part, and now it is showing OK to mesh the part. I am selecting yes. And now the mesh has been created. Okay. So after we create the mesh, all our steps are done. Finally, we have to create the job and then we have to submit that. Now to create the job, we can go to this job workbench from here, job. Okay, also we can go to this model tree. In the bottom, we have analysis and go to job, make a right click and click on create. So give it some name like job beam, and for the model, that is model 1, click continue. Here we are going to tell the software that what type of memories we are using. Like in general, how many of megabyte or gigabytes of memory is used into this analysis. Just take all these values as default and click continue. Then go to this job beam bottom, the job we have created. Make a right click. Here we can select the data check before submitting the job. So click on this data check. So by this option, the software is checking that all the data are proper or not. We can also check the status from here. Just select this job manager option. So after that, we need to submit this job. So click on this submit option, click OK. And now the software is going to solve this problem. Now the status is showing running, and now it is showing the analysis has been completed. After that, we need to click on this option of result. So in the next lecture, we are going to understand how to view the result. Okay, so till now our analysis has been completed. Hello friends, welcome to this course on Abaqus. In our first analysis, we were solving a beam problem. So till now, we had submitted the job and the job is completed. In this lecture, we will understand how to view the result and some more options to find out the stresses and deformations. So after we submit the job, we will see the option like this. The job is completed, it is showing from here, and now we need to visualize the results. Now to visualize the result, we need to go to the job manager. We need to make sure that job is completed from here, and then go to this module of job. Okay, job module, and click on this option of job manager. And here we will see the option that is called result. So go to result option, and now we are in the visualization module. So here we can see visualization. So first thing, we need to select the type of result we want to see. Here we can see the result. So it is showing primary, deformed and symbol. So I am selecting primary. After that, it is showing the type of output we want. So S means stress, U is the displacement. Okay, RF like reaction force, concentrated force like this. So I am interested in finding out value of stresses and deformation. So select stresses and the type of stress, von Mises stress, principal stress, etc. So I am selecting von Mises stress. Okay. So right now we can see this is the undeformed shape. So here we can see plot undeformed shape is highlighting. And now I am going to select plot contour on deformed shape. Just click on this. And now it is going to show the stresses. So the value of stresses, that is maximum value of stress, turned out to be 1000. So 1000 is 1000 megapascal. And then if we want to see how this beam is going to expand, we can view the animation of the simulation. Below we can find the option of animate scale factor. So click on this option. And now it is going to show the animation, how this beam is going to expand. Okay, we are going to apply this force in the right direction. So this beam is going to stretch like this. I am selecting animate harmonic option. Okay, now it is showing step by step. We can also go to the settings from here, animation option, and we can select the frame rate like slow and fast. Right now I am taking this as a medium. Then we can select play once, loop, etc. Okay, and then click OK. Now if you want to see the deformation, so go to this option of U and click on undeformed shape, and once again deform shape. So now the value of deformation we can see it is 2.38. So again this value matches the value we have calculated using the analytical option. So these are the result we have find out using the mathematical calculation, value of stresses and deflection. So these values matches with the analytical result. It means our analysis is correct. Once again I go to Abaqus. So if you want to find out where this result file has been saved, so right now I go to this file option and go to this set work directory. Click on this. So right now my default directory is C and temp file. So all the input file and this result file has been saved into this folder. So let's go to this folder. I go to C and go to temp. And now we can see the job we have created, that is job beam. So multiple files has been created into this folder. Now we need to focus on two files. The first file is INP file. Now that is jobbeam.inp file. That is the input file. So this file we have created, like we have applied the load boundary condition, created the mesh, everything is going to saved into this file, into this INP file. So that is input file. And for this input file we have a output file. So in Abaqus the output file format is called ODB file. So the format of this file is ODB file, job beam. Okay, now let's say I want to open this file. I will also share all these files with you. So I go to a new part file, click on this new and click on no. So if you want to see the result of the file we have created, so I go to, now first of all I'm going to open the input file. So go to file and click on import and go to part. Browse the location and in the type of file I'm going to select Abaqus input file, that is INP file. So that is the file job.beam and click OK. So once again I go to part. Okay, so go to part, double click on this and now we have our part file. So everything you can find into this part file. Now if you want to see the result once again, I go to a new file, so click on new, click no. Now I want to import the ODB file, that is output file for this job. So go to file and go to open. Now in the type of file I'm select output database, that is ODB file. And now I'm going to select job beam file and click OK. So now this is the result file. So you can open this file whenever you want.